Welcome to the conclusion of the lessons on analyzing functions, at least at the type of functions that we've dealt with so far. And our last topic here is extrema. And an extrema, it basically means an extreme point. And it basically means either minimum or maximum values on a graph. So if we look at a graph like this, let's say it had some features. Like this. So notice here we're looking for these top of the hills or bottoms of the valley here that we could consider within a certain interval. So if we pick some interval, like maybe between this whatever this point is and whatever this point is, within this interval, this point is as high as we can get. Okay, maybe we can get higher at other parts in the graph, but at least within this specific interval, there is one point here that is higher than all of the other points. Okay? And for now, this is the definition that we're going to go with. The formal definition is actually very tricky for us to handle. So right now, we're just going to work primarily with the intuitive sense of this, and it's going to be good enough for us. Okay? So in this particular example, let me label these axes here so that you can kind of see what these numbers are. So we'll say that point here is 1, it's -1, and this is -2, this is -1, -2, -3. Okay? So this point here is 2, -1. This point up here is 0, 1. This point over here is -3. Sorry, -2. Sorry, that should be -3. -3, -3, -3. Okay. So we say that these have extremas at 0, 1, 2, -1, and -3, -3. Okay. And we have to be careful with the notation here because these are points. These are specific points, not intervals. We've seen parentheses like this before. Sometimes they refer to points, other times they refer to intervals on a graph. In this case, we're talking about the points. Okay? And we can be more specific with this than just saying that the extrema at 0, 1, this is a max. At 2, -1, this is a minimum point since it's at the low end of the valley here. And then at -3, -3, this is also a minimum point. Okay? But then we can go even further than this and be more specific and try to get the difference between absolute versus local minimum. And let me sort of try my best to define this here. So an absolute minimum or maximum. So for something to be an absolute minimum, it has to be lower than all other points. Okay? This is an absolute minimum, is lower than all other points on the graph. Otherwise, the minimum is local. Okay? And we can see a good example of that. This right here is a minimum, but it's not the lowest point we can get. It's only the lowest point in this area. We can certainly get lower than that here at -3, -3. And this is the absolute minimum because it's also a bound. See? So at this point here also contains the boundary for the entire function. So -3, -3, this is an absolute minimum. For 2, -1, this is only a local minimum. And at 0, 1, well, let's see, is it the highest point that we can reach? Well, it's the highest in this area, but out here, there's a point higher than that. Over here, there's a point higher than that. So this here is only a local maximum. Okay, so absolute means that it is smallest for any particular point on the graph. Local means that it's just the smallest point for that particular area, or for the maximum, it's the highest point for that area. For the absolute maximum, it's the highest point for everything. So there's probably one more example on your notes, but I would like you to do this one on your own. This last one here is f of x equals x plus 1 squared minus 2, and it's asking for min, max, increasing, okay, decreasing. So please work on this particular problem on your own. Give these answers a hint. You might want to start with a graph. That's always going to make these problems a little bit easier, and draw the graph. Well, thank you for watching, and have a wonderful day. As always, if you have questions or things you do not understand, please ask your teacher.